Hey, it's Mr. Clegg. Let's simplify some rational expressions. All right, what that means is basically we're going to be canceling out common factors in the numerator and denominator. One thing to keep in mind is that when you're multiplying fractions, basically, you know how you just multiply across the numerator, you multiply across the denominator. And so you can pretty much treat this already as one big thing on top, one big numerator, and one big denominator. So there's not really any distinction between what's on the left-hand side and what's on the right-hand side. Everything on the top is on the top. Everything on the bottom is on the bottom. You could just extend this fraction bar straight across and it would be the same exact thing as long as you put multiply signs in between. So we'll start out by factoring out the top. So x squared can be written as x times x, 3 times x times x. The 2 just comes down. We can't do anything there. 2 is still 2. 9 is 3 times 3, and then x comes down there. We have to note that if x is in the denominator, we have to write down that there's a restriction there, meaning that x cannot be 0. And we still need to keep that in the final answer. All right, so we've factored this out. Now we're going to cancel out common factors. Now there's a 3 and a 3 there, so those can cancel out. There is a 2 and a 2 there that can cancel out, and an x there. And what we have left over is just x on the top and 3 on the bottom. So x is the numerator, 3 is the denominator. And we have to note that x still cannot be 0 because it couldn't be 0 to begin with, and so that restriction still has to stay. Now the restriction about x not being able to be 0 was really obvious here because it's in the denominator, and you can see that, well, x can't be 0 because it's right there. But once you cancel it out, that restriction is no longer apparent, so you have to make extra note of it right here. Okay, let's simplify this. No restrictions because there's no variable in the denominator. But let's just write out that this is 3x on the top, and the denominator would be 3 times 3. And so cancel 3 and 3. So we just get x thirds, no restrictions, x over 3. All right, next one. Note that the restriction here is f cannot be 0, g cannot be 0, because both of them are in the denominator to begin with here. Neither one of those can be 0. As long as they're not 0, we're good. So we got a lot of stuff we can do to this. On the top, we have 5f. And on the bottom, we have 5 times 5. And then we have f times f. I guess I should put times there. 5 times 5 times f times g. Make this a little longer. So now we can cancel out a 5, and a 5, and an f, and an f. So what do we have left? We have 1 on the top. That's what that means. Cancel everything out, you got a 1. We have a 5, an f, and a g. So we have 5, f, g with the restrictions. Okay. Next one, we have the restrictions here. Y is not able to be 0. X is not able to be 0. And actually on this one, with the f and g not able to be 0, it's still obvious because the f and the g are still in the denominator. So, you know, officially we didn't have to write that because you can see it there. Well, let's see what happens here. I think it's going to be the same thing again, where we're going to end up with an x and a y in the denominator, so it's not super important to write. So 8 and 24, I can already see that 8 divides into 24, so I don't need to write that this is 2 times 2 times 2. I could write that, but I'm just going to leave it as an 8 because I can see that it's going to cancel. I'm going to put xy. Okay, in the bottom, I'm going to have 3 times 8 See, that's my little secret there. I can see that the 8s are going to cancel. So I don't need to package them up. I've got these in a funny order, don't I? Put x, didn't mean to do that. X times y times y. Doesn't really matter, but the tradition is to put variables in alphabetical order in an expression. Anyway, 8 and 8 cancel out. The x and the x cancel out. That's a little bit hard to see that I canceled it, isn't it? There we go. And then a y and a y cancel out. So that's a 1 on the top, a 3, and a y. Okay, yeah, look at that. Okay, so we still need to explicitly state the restriction that x is not equal to 0. There we go. Might as well leave that one too, because it doesn't really matter, but it's obvious because y is in the denominator. Okay, look at this. P, I guess I'm really into restrictions today. P is not 0, Q is not 0, and R is not 0. All right, here we go. I can see that if this has a common factor of 7, I'm just gonna write this as 6 times 7. I'm not gonna write it as 2 times 3 times 7, because I can see that there's a 7 down there. Then I'm gonna put P times P times P, because it's P cubed, P times P times P. In the denominator, I have 7 times P times Q times R. Okay. Now, let's cancel out the 7, and the P, and the P, and that's it. Nothing else cancels. We have 6 P squared in the top, and QR in the bottom. Nice. And again, here I can see 8 and 48. Aha. I'm just going to write this as 6 times 8 in the top, 8 PZ in the bottom. That's a Z, by the way, not a 2. And I can cancel out the 8 here, the other 8, and the answer is 6 over PZ. And since the variables were the same as the beginning, the variables in the denominator are the same, so I don't really need to write down that P is not able to be 0 and Z is not able to be 0, because they're both in the denominator. In other words, I could write it, but I can write it that way, but it's not really necessary, because it's clear that they're still there. And now in the last one, we've got an x in the numerator. There's no x down here. There's nothing we can cancel. So I can just write already in lowest terms. Or simplest, let's put already in simplest form. That's the best way to say it. There we go. All right, good luck, you guys.